Hello friends, today we are starting differentiation. Differentiation means derivative of class 12. But its elementary, basic and elementary part is introduced in class 11. So first we will revise all the basic and elementary part. This is newly introduced chapter in class 11. So first let us revise the important result, important rules, important standard formulas which you have studied in class 11. So let us begin with the definition of function because we are finding differentiation of the function. So function means what? If A and B are two sets. So let A is one set and B is another set. If the element of these two sets satisfies certain condition, at that time we can say that there is a function from set A on set B. Let the element of set A are say 1, 2, 3, 4. Maybe possible that infinite elements are there in this set, but just to understand the definition of function, we have considered only 4 elements. And let the element of set B are say 1, 2, 3, 4, 5, 6, 7 and 8. Let 8 elements are there in set B. Now, since we have considered one very simple example, so we are supposing that let 1 is related with 2, 2 is related with 4, 3 is related with 6 and 4 is related with 8. Or in other words, we can say that 1 is associated with 2, 2 is associated with 4, 3 with 6 and 4 with 8. Now, we have taken one simple example. Now, observe the conditions. Now, first condition that every element of this first set means set A should be associated or related. So check whether how many elements are there in set A. Total 4 elements are there. Check whether every element is related or not. Yes, 1 is also related, 2 is also related, 3 is also related and 4 is also related. Means every element of set A is related. Now second condition, every element should be related with one and only one element of set B. Now 1 is related with how many elements? Only one element, that is with 2. In the same way, 2 is related with only one element 4, 3 is related with only one element 6 and 4 is also related with only one element 8. Means our both the conditions are satisfying that every element of set A should be related, and second condition with one and only one element of set B. If these two conditions are satisfying, at that time we can say that there is a function from set A on set B. The functions are denoted by any small letter. So let us denote here the function by f. So symbolically it will be denoted by this notation and it can be read as f is a function from set A on set B. So try to understand, this is the notation which says that f is a function from set A on set B. Now if the function is denoted by f, functions may be denoted by any small letter. As you stand here in this example, we are denoting the function by what? F. Now 1 is related with 2. So 2 is called as image. 2 is called as what? Image. Image of what? 1. Under which function? F. In the same way, 4 is called as image of 2 under the function f. 6 is called as image of 3 under the function f. In the same way, 8 is called as image of 4 under the function f. So what we have seen, 2 is called as image of 1, where 1 is called as pre-image of 2. In the same way, 4 is what? Image of 2, where pre-image of 4 is 2. Now symbolically it will be denoted by image of 1 under the function f is 2, so it will be denoted by f of 1 is equals to 2. In the same way, image of 2 is what? 4 under which function? F. So it is denoted by f of 2 is equals to 4. In the same way, f of 3 will be equals to 6 and f of 4 will be equals to 8. Okay. Now in this example, if you will observe that every element is related with its twice. This is one example. Not necessary that always 1 is related with 2. But in this example, every element is related with its twice. 1 is related with its twice 2. 2 is related with its twice 4. In the same way, 3 and 4 are related with its twice. Now suppose that one element x is there in this set A. Then what will the image of x under the function f? In this case, you will observe that every element is related with twice. Means in the same way, x will also related with its twice. What is twice of x? Will be equals to 2x. Means x will get related with what? 2x. So symbolically it will be denoted by f of x. F of x will be equals to what? x is related with 2x under the function f. So it is denoted by f of x is equal to 2x. So here we can say that this function is defined by which formula? F of x is equals to 2x. This is the formula by which the function is defined in this example. Now, if f is a function from set A on set B, then this first set is called as domain set. And this set B is called as codomain set. Okay. Now, let us consider the same example here. Now, 1 is related with what? 2. But 2 we have denoted by what? F of 1. 2 we have denoted by what? F of 1. Means image of 1 under the function f is denoted by what? F of 1. In the same way, 2. What is the image of 2? Image of 2 is 4. But 4 means what? F of 2. Means we can say that image of 2 under the function f is f of 2. In the same way, image of x under the function f is denoted by what? F of x. If you'll observe here, values of x are going on changing. What is the value? First value of x, 1. Second value of x is 2. Third value of x is 3. Value of x are going on changing. Values of x are changing. Changing means what? We can say that values of x are varying. That's why here we can say that x is what? Variable. X is what? Variable. Sometimes for simplicity functions are denoted by y. Means here function we have denoted by f of x. So here we can say that y is equal to f of x. Means this element in the domain set we are able to denote it by x, and element in codomain set. Is it a codomain set? And the elements are denoted by what? F of x. For simplicity, this f of x is also denoted by what? Y. Means if we are denoting f of x by y, means we can say that image of x is f of x, but f of x is what? Y. So image of x we are denoting by y. But here values of f of x are also constant, or maybe the values of f of x are also changing. In this example, what is the first value? 2, 4, 6, 8. Means as the values of x changes, values of this f of x are also changing. But f of x we have denoted by what? Y. So that's why we can say that y is also changing, means y is also varying. That's why we can say that y is also one variable. So values of this y are depend on the values of x. That's why y is called as dependent variable, where x is called as independent variable. So how many variables are there? X is one variable. As the values of x are changing, values of y are also what? Changing. But values of y depends on the values of x. That's why y is called as dependent variable and x is called as what? Independent variable. So the idea about function is clear. Let us consider another example of a function. So try to understand. We have to use this notation. Image of x under the function f is denoted by what? F of x. If we are denoting the function by what? Instead of f of x, if we are denoting function by y, at that time we can say that image of x will be equals to y. As the value of x changes, y also changes. That's why y is depend on x. That's why y is called as dependent variable. X is called as independent variable. At this time we have seen two variables in the function. Now consider another example. Now in this case, I am supposing that here one set is there. Let this set is say C and another set is say D. Let the element of set C are say -2, -1, 0, 1, 2. And let the element of set D are say 0, 1, 2, 3, 4. I am supposing that let -2 is related with 4, -1 is related with 1, 0 is related with 0, 1 is related with 1 and 2 is related with 4. Here let us denote this function say by G. Now check whether our conditions in the definitions are satisfying or not. What is our first condition? Every element of first set, means domain set, should be related. How many elements are there? Total 5 elements are there. And what is our observation? Every element is related. What is second condition? It should be related with one and only one element of set D. So -2 is related with only one element 4. minus 1 is related with only one element 1. In the same way 0 is also related with only one element 0. 1 is related with only one element 1. 2 is related with only one element 4. Don't observe codomain set that 1 has 2 tree images. There is no condition on what? Codomain set. All the conditions are on domain set. First condition, every element of domain set should be related. Yes, here every element is related. Second condition, that every element should be related with one and only one element. So yes, every element of domain set is related with one and only one element of codomain set. So here we can say that there is a function from set C on set D, and function we have denoted by G. So symbolically it will be denoted by this notation. G is a function from set C on set D. So C is called as domain set and D is called as codomain set. Now image of minus 2 under the function G is what? 4. So it will be denoted by G of minus 2 is equals to 4. G of, in the same way, G of minus 1 will be equals to 1. G of 0 will be equals to 0. And G of 1 is 1. And lastly, G of 2 is equals to 4. Okay, so because image of 2 under the function G is 4, so it will be denoted by G of 2 is equals to 4. In this example, if you observe carefully, minus 2 is related with its square. What is square of minus 2? 4. What is square of minus 1? Plus 1. So minus 1 is related with 1. Means every element is associated or related with what? Its square. So 1 is also associated with square. X, what is square of 2 is also 4. Means every element is related with its square. If suppose that one element X is there in the domain set, then definitely it will also associated with its square. Means what is the image of X in this example? X square. So symbolically it will be denoted by G of X is equal to what? X square. Means image of X under the function G is X square. So in this way, here function is defined by which formula? G of X is equals to X square. So we have taken two very simple examples of functions, and later on in the 11th standard we have seen how to find out limits of the function and continuity of a function. Even we have discussed the elementary part of differentiation also. So we will revise the elementary part of differentiation, considering that you know how to find out the limits of a function. Already you know that functions are of how many types, which you have studied in class 11. Algebraic function, this is also a simple examples of what? Algebraic function, simple example. Then you have studied about trigonometric functions, logarithmic function, exponential functions, and now we are going to find out differentiations of all these functions. In the 11th standard you have studied how to find out limits, how to check whether functions are continuous or not. Now we are discussing differentiation. So let us see how this differentiation is defined. So now let us discuss about definition of what? Differentiation. So try to understand this definition. Just now we have seen what is the definition of function here. So let us consider one domain set here, and let us consider here codomain set. Let the element of domain set is say X, and if I am denoting the function by F, then already we have seen that image of X under the function F is what? F of X. Okay. Now let us suppose that H is some increment in the value of X. So we are adding H in X, means value of X is changing, and this increment we have denoted by what? H. As the value of X changes, definitely value of this function also changes. Let us denote the change in the value of this function by, already we know that image of X under the function F is denoted by F of X. In the same way, image of X plus H under the function F is denoted by F of X plus H. Okay. Now these are the element in domain set, these are the element in codomain set. Now differentiation is nothing but what? Rate of change of one physical quantity with respect to another physical quantity. Only we are discussing this definition in terms of what? Functions now. Now we are taking difference of these two values. What is the difference here? F of X plus H minus F of X. Okay, F of X plus H minus F of X. And in the denominator we are taking difference of these two values. What will be the difference? This X plus H x plus h minus x. So here minus x and plus x will get cancelled. What will the remaining term then? H. In the denominator we have taken difference between these two values. If this limit exists, limit, here I am saying that limit h tends to 0. H tends to 0 means h takes the values very close to 0, and values very close to 0 are what? Very small. Means here increment in the value of x is denoted by h, and if you are saying that h takes the values very close to 0 means this increment is very small. But already we know that as value of x changes, value of function also changes. Only the value, if x changes but function does not changes, it happens only in case of constant function. Okay. Now, if this limit exists, how to find out the limit? When the limit exists, that part already you have studied in class 11. If this limit exists, at that time we can say that function is differentiable, and this derivative is denoted by f dash of x. And this is called as definition of differentiation, derivative by the method of first principle. This is called as definition of differentiation by using the method of what? First principle. Here f of x is given function on the open interval. The derivative of f of x with respect to x by the method of first principle can be found out applying this formula. And applying this formula, we have got some standard formulas to find out derivative of algebraic function, trigonometric function, logarithmic function, exponential function, and in class 12 we are going to prove some formulas to find out derivative of inverse trigonometric function also. Well, this is one of the definition which is called as derivative by what? First principle, or method of first principle. Hope the idea about this definition is clear to you. Now x is what? Some variable. If the value of exact value of that variable is given to us, suppose that here value of variable is say x is equals to a, and our aim is to find out the differentiation of the given function at x is equals to a, then it will be denoted by f dash of a. F dash of a is equals to limit h tends to 0, means simply we are replacing x by what? A, because we are finding the value of this x is variable, its value is going on changing. But if question is find out the value of derivative at x is equal to say 10, so we are replacing x by what? 10. As this time we are finding derivative of this function at x is equals to a. Then replace x by, on this side also, what we will get? F of replace x by, so a plus h minus f of a in the denominator, h keep it as it is. So this is the derivative of y is equal to f of x at x is equals to a, using the same method of what? First principle. So hope the idea about differentiation is clear. Now one mathematician is there whose name is Leibniz. So this note we are writing same definition but using another notation, and this another notation has been introduced by mathematician Leibniz. That's why it is called as definition of differentiation, or by Leibniz, or these symbols are called as Leibniz notation. So try to understand this definition. So let us denote the image of x under the function f by y. So here we can say that y is equal to f of x, means function, instead of f of x, function we have denoted by what? Y. So this increment in the value of x is denoted by delta x. Delta x represent increment. Here increment we have denoted by what? H. Instead of h, here increment in the value of x will be denoted by delta x. So definitely y is a function of x, means as x changes, y also changes. So here change in the value of y is denoted by delta y. These are the notation used by what? Which mathematician? Leibniz. Now here limit h tends to 0 is there. Limit h tends to 0. What is h? H is the increment in the value of x. But instead of h, here increment in the value of x is denoted by what? Delta x. So that's why here instead of x, we are denoting h by delta x. Instead of h, we have denoted this increment by delta x. So replace h by delta x here. So in the numerator, our definition says that in the numerator, take this difference. Now we are taking difference of these two values. So if we are taking difference of these two values, what we will get? Y plus delta y. From this value, we are subtracting y. So minus y and plus y will get cancel. So what is this difference? Difference is equals to delta y. And in the denominator, we have taken difference of these two values. So here also take the difference of these two values. If you are taking a difference of these two values, definitely x and x will get what? Cancel. What will the remaining term? Delta x. Now, if this limit exists, at that time, we can say that function is differentiable and derivative is denoted by what? F dash of x. Here, if the function is differentiable, then we will denote the derivative of y with respect to x by dy by dx. While whenever we are going to prove the theorems, in maximum theorems, we are applying this definition to prove the given theorem. So try to understand, this is called as definition of differentiation, or according to Leibniz, or simply it is called as Leibniz notation. So here we have written that definition. Here increment in value of x will be denoted by delta x, increment in the value of y will be denoted by delta y. Same definition is there. If this limit exists, we can say that function is differentiable, and derivative is denoted by what? Dy by dx. Here derivative is denoted by what? F dash of x. Again, see here, sometimes it is given to us that function is differentiable, means y is differentiable with respect to x. In theorem, it is given to us that y is differentiable function of x, means it will be denoted by dy by dx. If this differentiation exists, means limit exists, because our definition says that if limit exists, then function is differentiable. And in other words, we can say that if function is differentiable, means definitely this limit exists, isn't it? Applying these definitions, we have proved some standard formulas to find out derivative. Now we are not going to prove those formulas, so because that part already you have seen in class 11. Now we are preparing one list of formulas to find out derivative of some standard functions. So now these are some standard functions and these are their derivatives. All these formulas we have got applying the definition of differentiation. Now already you have proved these formulas in class 11. If you observe first three formulas are to find out differentiation of algebraic function. So derivative of x raised to power n is n into x raised to power n minus 1. So let us see what is this formula. So if the function is in the form of, say, y is equals to x raised to power 6, means if the function is in the form of x raised to power n, at that time applying that formula we are able to find out its differentiation. So differentiate this function with respect to x. So simply it will be denoted by this notation, differentiate with respect to x. So derivative of y with respect to x is denoted by dy by dx. Now this function is in the form of what? X raised to power n, where n is nothing but a natural number or any number. Not necessarily it will be a natural number. If the function is as you stand, the function is in the form of x raised to power n. According to this formula, first take this power n as an what? Coefficient. We have taken power as an coefficient and then decrease this power by 1. So what this formula says that first take power of x as a coefficient and then decrease the power by 1. According to this formula, what is derivative of x raised to power 6? First take this power as an coefficient. So we have taken this power in the coefficient and later on decrease this power by 1. So existent power is 6. So if we are decreasing, if we are subtracting 1 from it, it will become 5. So in this way we have got the differentiation applying first formula. So what is derivative of x raised to power 6 according to that formula? First take this power as an coefficient, then decrease the power of x by 1. In the same way, what will be the derivative of x raised to power 10? So then differentiate it with respect to x. So dy upon dx is equals to, again here if you will observe, function is in the form of what? X raised to power n. What is the power of n here? 10. So apply the first formula. According to first formula, first take this power as an coefficient and decrease the power by 1. So what will the new power then? 9. So how to apply the first formula is clear to you. Now we are taking here another example, say third. Y is equals to, say here x raised to power minus 7. At that time its differentiation will be equal. Differentiate it with respect to x. So its derivative dy upon dx is equals to, Now again here the function is in the form of x raised to power n. Our formula says that first take this power as an coefficient. What is the power here? Minus 7. If we are taking this power as an coefficient and decrease power by 1. So minus 7 minus 1, it will become what? Minus 8. Hope the idea about how to apply the first formula is clear. Now we are now the remaining two formulas in the algebraic function. If you observe the remaining two formulas, second formula and third formula, also we have got using the same formula. Let us see how we have got the second formula. So now here in the second formula, given function is y is equals to 1 upon x raised to power n. Now already we have got its differentiation. While solving the example, we are applying this formula, but now we are discussing how we have got this formula second from the formula number first. First, we are trying to convert this expression in the form of first formula according to laws of exponent, or we can say that laws of indices. If we are shifting this term in the numerator, its power will become what? Minus n. This plus n in the numerator, its exponent will become minus according to laws of exponent. Now we are differentiating it with respect to x. Differentiate with respect to x. So dy upon dx will be equals to. As it stands, this function is in the form of x raised to power n. But what is the value of n here? Minus n. Now according to first formula, first take this power as an coefficient. We have taken this power as an what? Coefficient. What is power? Minus n. We have taken it as an coefficient. Now decrease power by 1. So decrease the power of x by 1. As it stands, what is the power? Minus n. If we are decreasing it by 1, so it will become minus n minus 1. So which can be written as minus n, keep it as it is, x raised to power. If we are taking minus sign common from both the terms, so here we will get minus into n plus 1. Just simply we have taken minus common here. Now in the numerator, keep minus n as it is. Now according to laws of exponent or laws of indices, shift this term in the denominator. If we are shifting this term in the denominator, this negative power will become what? Positive. So what result we will get? X raised to power n plus 1. This negative power will become positive in the denominator. In this way we have got the second formula here to find out the differentiation. Now what is the third formula? Third formula is differentiation of root x. What is derivative of root x? 1 upon 2 root x. This formula also we have got from the same, means applying first formula we have got the third result. But now we are considering this third result also as a standard formula. See how we have got this proof. In this case, what is the function here? In the third formula, our function is y is equals to what? Root x. Now, can I write this root x as x raised to power 1 by 2? Because we know that square root of x can be written as x raised to power 1 by 2. In the same way, cube root can be written as x raised to power 1 by 3. Nth root can be written as x raised to power 1 by n. Now it is in the form of x raised to power n. And we have a standard formula to find out differentiation of x raised to power n. What is derivative of x raised to power n? First take this power as an coefficient. Well, we have taken power as an coefficient. Then decrease power by 1. As it stands, what is power? 1 by 2. We are decreasing it by 1. So decrease this power by 1. Keep this 1 by 2 as it is. Now what is the difference here? 1 by 2 minus 1 is minus 1 by 2. So which is equal to 1, keep it as it is in the numerator. In the denominator 2, keep it as it is. Now here if you will observe, power of x is minus. If we are shifting this term in the denominator, its power will become what? Positive according to laws of indices, laws of exponent. So it will become x raised to power 1 by 2. 1 keep it as it is, 2 also as it is. X raised to power 1 by 2. Can I replace it by root x? So because we know that x raised to power 1 by 2 means what? Root x. In this way we have got third formula to find out differentiation. What is the derivative of root x? 1 upon 2 root x. Now these are 6 formulas to find out derivative of trigonometric function. These formulas also, every formula is proved applying the definition of derivative. Now you have to remember these formulas. What is derivative of sin x? Cos x. What is derivative of cos x? Minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. Derivative of sec x is sec x into tan x. And derivative of cosec x is minus cosec x into cot x. If you, for simplicity, if you will observe this cos or cot or cosec start with what? C. First letter is what? C. If the trigonometric function start with C, at that time what is our observation? Derivative is negative. Means when the derivative is negative, this is just for simplicity, how to remember these formulas, or when the derivative of the function, when the derivative of trigonometric function is negative. If first letter of the trigonometric function is C, at that time our observation is that derivative is negative. Now you have to prepare the formulas, because applying these formulas we have to find out the differentiation. Next two formulas are to find out derivative of exponential function. Derivative of e raised to power x is e raised to power x. Derivative of a raised to power x is a raised to power x into log a, where a is what? Any constant. A is what? Any constant. 5, 6, 7. It takes its value is any real number. Then next two formulas are to find out derivative of logarithmic function. What is derivative of log x? Log x is equal to 1 by x. As a stand in calculus, calculus means what? It is the branch of mathematics in which we are studying functions, and here this is nothing but a list of derivative of a function. This second paper is called as what? Calculus. Now in calculus we are studying derivative of natural logarithm. Natural logarithm means here in the base nothing is written. Nothing is written means it is considerable that base of this logarithm is what? E. In the base nothing is written means it is considerable that here base of this logarithm is E, and if the base of logarithm is E, at that time it is called as natural logarithm. So here and here also these angles x are measured in what? Radian. It not necessary to write down the radian, sine x radian. If unit of measurement is not written here, so it is considerable that the unit of measurement is what? Written. Unit of measurement is radian. So hope the idea is clear. If unit of measurement is degree, at that time definitely you have to mention that this angle is measured in what? Degrees. If nothing is written here, it is considerable that here radian is there. In the same way, in case of logarithmic function, in the base nothing is given in the base, so it is considerable that base of logarithm is E here. And such logarithms are called as common logarithm. Instead of E, if we have to use any another number, at that time it will be denoted by A, and its derivative can be find out applying this formula 1 upon x log a. So let us suppose that if function is, say, y is equal to log of x to the base 7. Here what is the value of a? A is equal to 7. At that time its derivative will be equals to dy upon dx. According to this formula, its derivative is 1 upon x log a. But what is the value of a here? 7. So here its derivative will be 1 upon x log 7. So hope the idea about how to apply this formula is clear. And the last one is derivative of constant function. Derivative of constant function, say 6 is also constant, 7 is also constant, and means variable does not appear. Variable here we have denoted by what? X. If variable does not appear in a term, at that time such terms or such functions are called as what? Constant function. And what is derivative of constant function? 0. All these formulas we have proved using the definition of differentiation. Now let us discuss some important rules to find out the differentiation. Here 14 important formulas are there. Again in class 12 we are going to find out 6 new formulas which are called as derivative of inverse trigonometric function. That part we will discuss later on. Now try to understand these 4 important rules. To find out the differentiation, standard formulas and rules are very important. Now if u and v are differentiable function of x, differentiable function means their derivative exists. If these are differentiable function, then addition rule. Addition rule says that what? U is also differentiable function of x and v is also differentiable function of x. All these are nothing but what? Differentiable function, and these are their derivatives. Okay. Now if u and v are differentiable function of x, then by taking their addition, if we are getting one new function, by taking their addition, which new function we have got here? Y. So we have denoted addition of these two functions by y. Then to find out the derivative of y, we are applying what? Addition rule. So derivative of y is equal to dy by dx. In such cases, first find out derivative of u. So it will be denoted by du by dx plus, and derivative of v with respect to x will be denoted by dv by dx. Means addition rule says that if u and v are functions of x, differentiable function of x, then how to find out derivative of what? New function, which we are denoted by y. So to find out derivative of y, first find out derivative of u. Then keep plus as it is, then find out derivative of v. Just we will try to understand how to apply this formula while solving the example. Suppose that one function is there, say y is equals to x raised to power 5 plus sin x. In this case, two functions are connected by what? Plus. At that time, while differentiate it with respect to x. So derivative of y denoted by dy by dx. Now first find out derivative of first function according to what? Addition rule. What is first function here? U. First find out derivative of u. Later on keep plus as it is, then find out derivative of v. So here what is u here? X raised to power 5. We are finding its derivative. Now this term is in the form of first formula. Which formula? X raised to power n. So according to first formula, take this power as an coefficient and decrease power by 1. Keep plus as it is. Now we are finding derivative of second term, means derivative of sin x. What is derivative of sin x? Cos x. So in this way, we are solving the example applying what? Addition rule. Now let us see how to apply the subtraction rule. In case of subtraction rule, if u and v are a function of differentiable function of x and we are getting new function by taking their subtraction, at that time to find out this derivative, we are applying subtraction rule. According to subtraction rule, first find out derivative of u, that is du by dx, minus keep it as it is, then find out derivative of v, means dv by dx. Now consider one example, otherwise consider the same example. Instead of plus, if minus is there, at that time we are applying subtraction rule. According to subtraction rule, first find out derivative of first term. Already here how we have got this differentiation is known to you. And if minus is there, here also write down minus. Then find out derivative of sin, that is equal to cos x. In this way we are applying subtraction rule. Now the very important part of this chapter is product rule and what? Quotient rule. Whatever may be the method we are applying here some different rules we have different method we have to apply in case of product. If two functions are there which are connected by what? Multiplication, means product of two function is there. At that time to find out its derivative, first keep first function as it is, means u as it is, into derivative of v, means dv by dx, means first term as it is, derivative of second term, plus second term as it is, means v as it is, into derivative of u, means du by dx. In this way we have got product rule, means first term as it is, derivative of second term, plus second term as it is, into derivative of first term, means first term as it is, means u as it is, into derivative of v, and then plus v as it is, means second term as it is, into derivative of first. This rule is called as what? Product rule. So let us try to find out its derivative applying. Let us consider one example and we are finding its differentiation applying this product rule. Let y is equal to say x cube into tan x is one function. If you will observe here, multiplication of two function is there. If multiplication means product of two function is there, at that time while finding differentiation, differentiate it with respect to x. At that time while finding differentiation, we have to apply which rule? Product rule. According to product rule, what product rule says that keep first term as it is, means x cube as it is, into derivative of second term. What is second term? Tan x, plus second term as it is. Second term as it is means what? Tan x as it is. Tan x as it is, into derivative of d by dx, means derivative of first term. What is first term here? X cube. In this way we are applying product rule. Product rule says that keep first term as it is, derivative of second, plus second term as it is, into derivative of first. Now we have just substituted the values in the product rule. Here first term as it is, derivative of second term, plus second term as it is, into derivative of first term. Now remaining part is simplification. So let us simplify it. X cube, keep it as it is. Now we are finding derivative of what? Tan x. Our standard formula says that what is derivative of tan x? Sec square x. Derivative of this tan x will be equals to sec square x, plus Keep this tan x as it is, tan x as it is. Now we are finding derivative of x cube. This term is in the form of what? X raised to power n. So we are applying this formula to find out its differentiation. According to that formula, first take this power as an coefficient and decrease power by 1. Once the differentiation is known to us, if you want to if it can be simplified, you are able to simplify it. So hope the idea about how to apply the product rule is clear. Later on we are solving some examples applying this rule also. And last one is quotient rule. So let us see how to apply the quotient rule while solving the example. But before that, first try to understand what is quotient rule. Quotient rule means division of two function is there. If u and v are differentiable function of x, and now we are finding derivative of such function which are in the form of u upon v. U upon v means division of two function is there, and such that rule is called as quotient rule. In the quotient rule, keep v as it is. V as it is into derivative of u means du by dx minus u as it is into derivative of v divided by v square. If you are solving 20-25 examples, you are easily able to apply this rule also, and this formula will also get prepared. So let us try to solve one example applying quotient rule. So now consider one example here. Let the function is equals to y is equals to say sin x divided by say cos x. Now the function is in the form of u upon v. What is the value of u here? Sin x. What is the value of v here? Cos x. Now differentiate it with respect to x. So dy upon dx is equals to, according to quotient rule, first keep v as it is. What is v here? Cos x as it is, into derivative of sin x. So into derivative of sin x minus u as it is. U as it is means what? Sin x as it is into derivative of v. What is v here? Cos x. This is u and this is v. Derivative of cos x divided by v square. What is v here? Cos. So divided by cos square x. Now just we have substituted these values in this formula. What is u? Sin x. What is v? Cos x. This formula says that keep v as it is. V as it is means cos x as it is into derivative of u. What is u here? Sin x into derivative of sin x minus sin x as it is. Sin x means u as it is. U as it is into derivative of v. V is cos divided by cos square x. Now let us simplify it. In the numerator, keep this cos x as it is. What is derivative of sin x? According to our standard formula, derivative of sin x is what? Cos x. So replace this derivative of sin x by cos x. Minus also keep it as it is. This sin x also as it is. Now derivative of cos x. Our standard formula says that derivative of cos x is how much? Minus sin x. So replace this cos x by minus sin x divided by cos square x, keep it as it is. Just here two terms of differentiations are there. Derivative of sin x is cos x and derivative of cos x is what? Minus sin x. Let us simplify it. Here cos into cos square x minus sin x into minus sin x will be plus sin square x divided by cos square x, keep it as it is. Now let us simplify. Differentiation is completed. How many terms of differentiation are there? Two terms. Now remaining part is simplification part. So hope you have studied trigonometry in class 11. Prepare the list of all formulas. Means which formulas? Identities, again factorization formulas, defactorization formulas, compound angle formulas, allied angle formulas, half angle, double angle, triple angle formulas. All these formulas should be known to us while finding derivative of trigonometric function. According to identity, sin square x plus cos square x will be equals to 1. 1 upon cos square x. And 1 upon cos square x can also be written as sec square x. In this way, we are applying quotient rule to find out the differentiation. So as you stand, how many standard formulas we have written? 14. And how many rules are there? 4 rules are there to find out derivative. In the next video, we will do the practice to apply these 4 rules and how to make the use of these standard formulas while finding differentiation.